So good afternoon. So today we are going to design a solar PV system. Okay, sir, how to design an solar PV system to your house? How to design a solar PV system to an engineering college? How to design a solar PV system to an industry? So the design process comes in reverse engineering. So first, generally the power flows from solar system to battery, from battery to charge controller, from charge controller to inverter, from inverter to the load. Okay, so this is how the energy flows. But while we are designing the system, you should consider the reverse energy flow. Okay, so first you should calculate the load requirement. From the load requirement you have to calculate inverter design. From the inverter rating you have to calculate the charge controller rating. From charge controller rating you have to calculate battery size. From battery size you have to calculate how many solar panels are required. So coming to the design, when you are designing a solar PV system, you should follow the reverse energy flow. Okay, so previously the energy flow was like this. Okay, so the energy flow was made in this direction. So first the energy flow is from solar to battery, battery to charge controller to inverter. The blue color line indicates the original energy flow, but the black color line indicates the opposite of energy flow, where this opposite of energy flow will be help us in designing a solar PV plant or a solar PV system. So how to design or how to make it, let's try to do with an example load. Okay, so let's try to take a load. First, what you need to calculate, what is the type of load we have. Based on this, for example, for this given load and for the given number of hours, you need to calculate the solar panel rating, battery rating and charge control rating, and what kind of inverter is required for this given amount of load. So you should perform in which engineering? Reverse engineering. So which is nothing but black color line what I have been indicated. So for this problem, today we are going to design a solar power plant. Okay, so the given loads are, a fan is there, the rating of that fan is 100 watt, it's a old fan, and how many quantity are available is only one quantity is available. So total is how much? 100 watts into 1 is the total power. So 100 into 1, I want to calculate the energy, multiply this power with time. Okay, so now 100 into 6 is how much? 600, and the units are watt hour. Is nothing but energy required. So coming to the second load, so in the problem it is given as we have two tube lights, each tube light rating is of 50 watts. So what is the resultant power? So 50 into 2, 50 into 2 is how much? 100. So 100 watts is operated for 8 hours. What is the resultant now? 800 watt hour. Next one, he has 5 CFL with the power rating of 18 watts, and they are operated for 5 hours. So 18 into 5, how much? 90 watts, and this 90 watts is operated for how many hours? 5 hours. What is this value? 450 watt hour. Okay, next he has one LED TV. How many quantity? One quantity. So 80 into 1, which is nothing but 80 watts, and this 80 watts is operated for 5 hours. How much it is? 400 watt hour. Now calculate the sum of the power. So calculate the sum, 100 plus 90 plus 80. 2. How much? 2. So calculate the total power and total energy.
Total watts is 370.
370 watts. And what is the total energy? 600 plus 800 plus 450 plus 400. 2250 watt hour. So now for this given power rating and for this given energy rating, we need to design our inverter, we need to design our charge controller, we need to design our battery size, and we need to design our solar PV system. Okay, so now coming to the inverter design. Okay, so what is the rating of this inverter? Okay, so we have a load. This is a given load, and this load requires this much amount of power and this much amount of energy. So second one is what we need to design is an inverter. Okay, so how to design an inverter? So what is the formula of an inverter? Let's try to take the efficiency of an inverter is equal to output power divided by input power. Okay, so efficiency can be written as output divided by input. Okay, so what is the output of the inverter? Output of the inverter is nothing but what? The load. Okay, so the output of the inverter is nothing but the load power required. And what is the input power? We don't know how much input power you have to give. Okay, so we know the load, I mean output power is known to us. From output power and efficiency we need to calculate how much input power we need to give. Okay, so let us consider. Similarly, we need to calculate efficiency also. I mean, we need to calculate not only the input power required, we need to calculate input energy also. So efficiency can also be written as energy output required by the load divided by the energy input required by the inverter. So let us assume the efficiency of the inverter as 23%. So efficiency of the inverter, we are assuming it as 93%. Okay, so now efficiency is known to us and output power is also known to us. So how to calculate? And we know the relation input power is equal to output power plus losses. So in input and output, which is greater? So with the input power and output power, which is greater? All the time input power is greater than output power. So input power is greater whereas the output power is lower. Okay, now let us try to calculate the input power. So I am going to find out the input power required by the inverter. Calculate what is the efficiency of the inverter given? 93%. So now the input power is equal to, what is output power? Output power is 370 watts divided by efficiency. How to write down the efficiency? Percentage. So 93% is 0.93. So say the amount of input power? 397.84 watts. Okay, so 397 we don't have the outer rating in the market like this. Therefore, what is the rating of the inverter? 400 VA. The rating of the inverter we require is 400 VA. Now coming to the energy required, how much? What is the input power to be supplied to the inverter is 400 VA. The power rating of the inverter is how much? So the load is of 370 watts. The inverter rating is of 400 VA, and we need to calculate what is the input energy to be supplied to the inverter. What is the output energy of the inverter? Output energy is nothing but the load. It's already known. Okay, so the energy input to be supplied to the inverter is equal to, what is the energy output? What is the energy output? Energy output is nothing but the load. What is the load? Load requires 2250 watts divided by efficiency is how much? So we are taking the efficiency of the inverter is 93%. So 93% can be written as 0.93. So calculate this value. 2250 divided by 0.93. 2420 watt hour is the energy input to be supplied by the inverter. Okay, and the power rating of the inverter is 400 VA. And coming to this inverter rating, so generally inverters will be of 400 VA divided by 12 volts. Why? Because inverter will be have either 12 volt system or an 24 volts system. So divided by 12 volts. Calculate the current required. 33. So we can approximate this as 34 amperes. So we need to buy an inverter. What is the rating of the inverter? 400 VA inverter. What is the system voltage? 12 volt system. It in such a way it can withstand a current of 34 amperes. Now what are the things we have been designed? So for the given load we calculated the power rating of the inverter is 400 VA. What is the system voltage? Where this 12 volts is called as which voltage? system voltage and how much current it can handle? 34 amperes.